सिर्फ थोड़ा सा ये कि just one second. Start here. अच्छा बस ये चलो ठीक है uh, थोड़ा सा ये कि we'll start with electrolysis अच्छा we'll start with electrolysis लेकिन before we start with electrolysis what do we हाँ अच्छा before we start with electrolysis we need to revise a few things before we can actually start completely with electrolysis. And the few things are, okay, I'm just going to quickly revise because electrolysis mostly the compounds, but let me write the definition of what electrolysis is. It is the decomposition of an electrolyte by passing current. Yeah. So it's Taha, if you could mute your mic. Sorry. Achha, so it's the decomposition of an electrolyte. And what's what's an electrolyte by passing electricity. They're going to ask you this. So this definition is important. Decomposition means breakdown. Basically, the compound would break down into, and it's going to produce different products. And electrolyte, what's an electrolyte? It's anything that's got free moving ions. Either aqueous or molten. Aqueous means whether they're aqueous or molten. So it could be any ionic compound, compounds, acids, bases, salts, anything that has free moving ions, that will be called an electrolyte. And by passing electricity, you already know what electricity is. I said, but before we move on, a breaking down of ionic compounds or compounds that contain ions by passing current, we need to just revise quickly about ionic compounds and their formulas. Okay, so revision. Okay, this is something that, there's some previous topic revision. So that is formulas of ionic compounds. So I'm just going to do this quickly. Okay, we can recap everything because that's important. So formulas of ionic compounds. And remember, in the periodic table, you need to know which group forms which ion. Okay, you got group 1, group 2. Then you have group 3, group 4, group 5, group 6, and group 7. I'm going to ignore the noble gases. Group 1 will have a +1 charge. Group 2 is anything that's in group 2 is going to have a +2 charge. Anything that's group 3 that will have +3 charge. Group 4 normally don't form ions, but they could form +4, -4 ions. And then you have negative ions, normally -3 for group 5 because it already has 5 electrons. So it gains 3 electrons. This one will have -2. This one will have -1 charge. Okay. Hopefully everyone knows this. Group 7 has 7 valence electrons. So it's going to gain 1 electron. Okay, group 5 has 5 valence electrons, so it's going to gain 3 electrons to complete its outer shell. Non-metals are on that side. Okay, these are non-metals. And metals are on the left side of the periodic table. And then you have in the middle maker in the middle, right in the middle, you have your transition metals. And they have variable, the word that is used is oxidation states or charges. So they have transition metals have variable oxidation states. That means they could be iron could be +2, and iron could be +3 as well. It could be +4 as well. But they can have variable charges. They can lose 2 electrons, they can lose 3 electrons, they can lose 6 electrons if they want to. Or if somebody is able to pull electrons out of them, then they can. So, but you don't have to worry about that because it's going to be written in the question. You don't have to guess. मतलब लिखा होगा, if it's iron +2, then they're going to write iron 2. If it's iron +3, they're going to write iron 3. Otherwise, there's no way of you knowing what the charges are. So I'm just going to write a few elements. Okay, so sodium, potassium, etc. are over here. Mgs, Ca, Sr, Ba. These are the aluminium is in group 3. Group 4 has carbon and silicon. Nitrogen, phosphorus are over here. You've got oxygen and sulfur, and you've got fluorine, chlorine, bromine, iodine. Okay, these are the more common elements that you're going to encounter. We're going to learn how to make an ionic compound and their properties. Okay, again, a quick recap. A metal is the one that's going to lose electrons, always loses electrons, it always forms positive ion, and a non-metal is the one that always likes to it gains electrons. So you got a positive ion, and you got a positive ion because it's losing electrons, and you've got a negative ion. Why? Because it gains electrons. This is known as a cation, and the other one is known as the other one is known as the anion. Okay. अच्छा, so camera on you, right? अच्छा, you got cation and you got anion. Nabila, we started electrolysis. ठीक है. Yabina, हम उसका ना पिछला we trying to recap everything. So यानी जो base the things that are required, I'm just going to do that quickly. Ionic compounds. I think you got a positive ion, you got a negative ion, and they're obviously going to attract each other, and they will have strong electrostatic attraction between them. That's known as so there's strong electrostatic attraction. You get positive things attract negative things, and that's basically known as your ionic bond. Okay, now I'm going to come to the properties and the structures, and again, very briefly, very quickly. Okay, what are the structures and properties of ionic compounds? The first thing is the structure of ionic compounds that form they form giant ionic lattice. What is a giant ionic lattice? It's a regular arrangement. It's a regular arrangement of positive and negative ions. Strongly attracted by, or simply attracted by strong electrostatic attraction. Attracted by strong ionic bonds, basically. So attracted by ionic bonds. And you should know how to draw the giant ionic lattice. What's the giant ionic lattice? अच्छा जो भी है उनके लिए मैं फिर बता दूं. We started electrolysis, and we're just recapping ionic compounds because that has something to do with electrolysis. अच्छा, so you'll have positive ions and you will have negative ions, and they will strongly attract each other, but it's not going to be one. It's going to be a giant lattice. It's going to be an endless. It's going to be a huge crystal of negative ions attracting positive ions, which इधर ले आते हैं और इधर एक I need one positive ion. अच्छा, so So that's your crystal structure of what your ionic compound looks like. So positive and negative ions all attracted to each other. It has certain properties, so we're going to talk about the properties very quickly. क्या property? अच्छा, can anyone tell me what the properties were for ionic compounds or ionic lattices? कोई भी बता दे, Zarar, any idea?
High melting and boiling point due to the strong force of attraction.
So it had high melting points and boiling points. Uh, इस वजह से strong. Second property, what's the? I mean, they all attract each other very strongly. What's the other property? What about क्या और properties इसकी? Do they dissolve in water?
That they dissociate in water.
So they dissociate and basically dissolve in water, right? And what happens when you try to mix them in water? They dissociate. There's a word, there's a very specific technical word that should be used when you describe it. Ionize word use. I mean, ionize is not the right word. It's dissociate because they're already ions, so they're not ionizing. So if you have water and you try to stir this with a spoon, so the ions will scatter. If it's very soluble, then all the ions will एक इसको एक ये उठा लेते हैं. अच्छा, so the ions will get. This is what happens when you dissolve your table salt in water. Where does it disappear? It basically all the ions they completely scatter. They completely scatter and they mix in water. And water is going to keep them separate. There would be so many water molecules in the middle. यहाँ पे there would be so many water molecules that it would be very hard for them to join back again, unless they'll start forming crystals if what happens they uh, I said they start forming crystals if there's not enough water left. So फिर they will all start joining up with each other. ठीक है? अच्छा, anyways, अब next चीज है कि remember we have to do electrolysis, by the way, so this is important. They dissociate in water and therefore they conduct electricity when what happens
When they're in aqueous or molten form.
when they're in aqueous or molten state. ठीक है? Why? Because of free moving. I mean, if they ask you why do they conduct electricity when they're molten or in aqueous state, because in that state they're going to have free moving ions, charged particles. Only in that state will they be conducting electricity. Or either I'm disclaimer like that, not in solid state, because in solid state the ions cannot move. They cannot move, so they can't carry charges. I mean, the charged particles cannot move from one point to the other point, so that's not going to happen. So free moving, ये आपसे वो बहुत पूछेंगे, free moving ions. And that's the important thing. Dissociation is all in water, right? Now, that's about electric conduction and the properties of ionic compounds, that they dissolve and they dissociate. Okay. I said the next thing is, before we continue, we'll talk about, because this chapter has to do with electrical conductivity. We'll talk very quickly about metals and alloys, because they're also good conductors of electricity. Okay, now there's going to be one difference. So what is the metallic structure? That's known as a giant metallic lattice. Okay, what does it look like? It's metals. They like to lose electrons. So if you just have metal atoms, so what will happen is they will all start to lose electrons. And so they will all start losing electrons, and they'll form a lattice of positive ions. And where would the electrons go? Okay, there's no one gaining those electrons, so the electrons are just, you got a sea of mobile electrons or sea of delocalized free moving electrons. Okay, now you need to understand the difference. Okay, ionic compounds where the electricity is conducted by ions, charged particles that are floating around. While if you have metals, so you have a giant metallic lattice, where though just for revision, we'll write down the definition again. Okay, what is it? It's a regular arrangement of positive metal ions in a sea of mobile, delocalized, you get the different words, free moving, you get sea of mobile electrons, right? You get that's a giant metallic lattice. Achha, but the important thing about here is that Baki property side, where the only property I'm interested in at the moment is that it conducts electricity in all states. And why does it conduct? Because it has free moving, your mobile, your delocalized electrons. It's got a lot of electrons that are freely moving around that can carry charge. Okay, so if a negative electron wants to jump from this point to the other point, a negative charge is going to get transported, right? So so metals they always conduct electricity. I said, but there's one major difference. When I talked about ionic compounds, and when I talked specifically about electrolysis earlier, yes, stuck हो गया actually. अच्छा, ऊपर चले गया. So when I talked about electrolysis or the decomposition or the breakdown. Now this is something that's very important. This breakdown or this decomposition only happens for electrolytes, which are basically ionic compounds. Because things that are free moving ions. So a metal does not decompose. So the term electrolysis, a metal is a very good conductor of electricity. But the term electrolysis, it doesn't really apply to metals. So keep this in mind, metals, they don't get electrolyzed. Uh, they don't break down. I mean, you've never seen a wire breaking down into different things and forming new compounds. They don't break down when conducting or when current is passed through it. So keep this in mind that ionic compounds, they break down when you conduct electricity through them. So, but this doesn't apply to metals. The only thing that happens in metals is, yeah, on one side the electrons are coming in, and the other side the electrons are flowing out, and the metal remains completely unchanged. Okay, for example, this electron goes to one side, and there's another electron coming from the power station or somewhere, and it replaces it. Okay, so there's a constant flow of electrons, but the structure doesn't really change. Okay, there are 10 electrons coming from the left. Okay, let's say from this side. There's a wire connected. There are 10 electrons coming from this side. They come in, and there are 10 electrons leaving from the other side. So the metal structure completely remains unchanged. Okay, it remains exactly the same, even though electrons are flowing through it, uh, but it remains completely unaffected. ठीक है, तो इसलिए आपके घरों में जो wires होती हैं, they can last for like uh, 10 year, 20 year, 30 year without, I mean, there's constant electricity flowing, but nothing happens to them. So keep this in mind. Metals are not going to be electrolyzed. Okay? And when you talk about metals, alloys are something that's very similar to metals. The only difference between a metal structure and an alloy structure, क्या difference था? Can anyone tell me what's the difference between the structure of a metal and an alloy? Just a tiny difference. What's that tiny difference? कोई भी बता दे. Taha, Zarar, anyone, Nabila? Like if I were to draw an alloy, Ibad,
जी सर क्या
क्या difference है alloy और उसमें metal में?
सर एलॉय में साथ में यहाँ कोई और भी एलिमेंट होता है इम्प्योरिटी होती है कोई
Let's see. बस वो छोटा difference होगा कि it's going to have an irregular metallic lattice, right? कि there's going to be some impurity and that will make the structure irregular. That's it. Otherwise, मतलब इसको मैं, the only thing I'm going to do is I'm going to इसको replace करके I can add an impurity, and the impurity will have maybe a smaller size. So if that is the case, the structure over here will become slightly, it will become slightly irregular. Okay, electrons. The electrons are roaming around exactly the way they were before. So, so the only difference between an alloy and a metal is, otherwise the properties are the same. Alloys are just slightly stronger and slightly harder because of the irregular arrangement. The layers cannot slip and slide. So when you hammer it, it's so irregular that it's very hard to sort of slip and slide for the ions. But anyways, important point, important takeaway is metal and alloys will conduct electricity, but they'll never get electrolyzed. So who else conducts electricity? There are a few more. Okay, we talked about metals. There is कौन करता है electricity conduct? There's graphite, right? There is one giant covalent structure. So there's one giant covalent structure which is graphite, which is which has got banal in it. Graphite is, there's a carbon atom, and so those carbon atoms are all bonded to each other, and they, so each carbon atom is making 3 bonds. And graphite is like a really, really good conductor of electricity. Okay, and it just continues. I mean, it's going to be the आगे बना रहा होगा, ठीक है? So it just continues endlessly. And graphite is a sheet-like structure. So there's going to be one sheet, and below it there's going to be another sheet. इसको थोड़ा, oh, अच्छा, below this there's going to be another sheet. तो ये इधर है, फिर ये, अच्छा ये था, अच्छा, so it's going to be a sheet-like structure, and it's going to have weak van der Waals forces. So graphite is basically carbon. It's a form of carbon. It's known as an allotrope of carbon. So it's an allotrope. So, and there are going to be weak intermolecular forces between the sheets. So it's a layered sheet-like structure, completely flat, with weak intermolecular forces. forces known as van der Waals. Van der van der Waals. Okay, so that is what makes graphite really soft. Okay, the sheets of graphite can slip and slide. Okay, your pencil, wo jo lead in the pencil, that's basically graphite and clay. So it kind of slips off. Okay, I mean the sheets can sort of slide out of it. So it's very soft, but it's got a very high melting point because there's so many bonds that it's very hard to melt. But it happens to be a very good conductor of electricity because it has delocalized electrons that are moving around in the sheet. Carbon has 4 outer electrons, but the problem with graphite is graphite only makes 3 bonds. So out of 4 electrons, 3 are bonding, and the 4th electron is not doing anything. So it's an extremely good conductor of electricity. So just like a metal, it's got delocalized electrons. Why? Because of mobile, free moving, delocalized electrons. Okay. So again, for graphite, maybe the same thing is happening. Nothing happens to it when electricity gets conducted. Electrons come from one side. Let's say there's a wire connected. These electrons get pushed further away. There's another wire over here. The electrons move on. So there's a constant flow of electrons. But at any point, the structure of graphite does not change. The electrons over here, I mean, they continuously get replaced. मतलब यहाँ से आ रहे हैं, they're getting pushed from the other side. But the amount of electrons in the graphite structure, they exactly remain, the number of electrons would remain exactly the same. So remember for graphite as well, uh, keep this in mind, nothing happens to it. It doesn't break down, nothing happens to it, happens to graphite when electricity flows through it. चलो ठीक है ये क्लियर है सारा को Taha, Rania, Ibad, is this clear to everyone?
जी सर
अच्छा see मैंने मिस देखा this one अच्छा अब ठीक है तो मेरा वो MP और PP melting points boiling points थे ठीक है अच्छा anyway so this is graphite so there's another this is one तो अभी क्या हुआ what we have done is ionic compounds were conducting electricity right but why were they conducting because they were positive and negative ions floating around in aqueous state or in molten state but not in solid state ठीक है in solid state it's not going to conduct electricity. So then I talked about metals. They conduct electricity because they've got free moving electrons. Alloys as well. Graphite conducts electricity because it has free moving electrons. So there's a fourth thing that conducts electricity, and that is those are actually covalent molecules. Covalent molecules are not supposed to conduct electricity. First thing. Okay, the first thing is you got any covalent molecule, they don't conduct electricity. ठीक है पहले वो लिख लेते हैं. So covalent molecules, without a doubt, they don't conduct. Except for graphite, that was the only one. So they don't conduct electricity. So why do they not conduct electricity? Because they're mostly sharing electrons, the oxygen or chlorine. You got a chlorine molecule, it's Cl with अलग कर लेते हैं इसे. So you got Cl, it's got let's say 7 electrons. And there's another Cl and that's got 7 electrons. So because they're both non-metals, they don't lose electrons, so they start to, because they need electrons, so they start attracting each other's electrons. And then what happens? They start sharing those electrons. Okay, so it's like two people trying to gain electrons. Non-metals, they always like to gain electrons. Okay, covalent molecules are formed by non-metals. So they always like to gain electrons, and when they're trying to pull each other's electrons, they end up sharing electrons. Okay, so they end up sharing electrons. So they don't have no free moving ions are present. I mean, they never formed ions. They never lost electrons. They ended up sharing electrons. Or free moving delocalized electrons. I mean, there are no electrons that are roaming around. Mobile, delocalized. Achha, so remember, if they're going to ask you why covalent molecules don't conduct electricity, they don't have any ions free moving or any charged particle or any free moving mobile electrons to do that. Achha, but Ismina, there is not an exception. Okay, covalent molecules don't conduct. Okay, that's without a doubt. They never conduct. It's not their property. Okay, they're never going to conduct electricity. But sometimes what happens is that some covalent molecules they hydrolyze or react in water or dissociate in water or ionize in water. You can hydrolyze or I mean you can use the word react. Hydrolyze word जो होता है ना, that is when something reacts with water and breaks down. I mean lysis is the word. Whenever you hear the term lysis, it's an electrolysis. ठीक है, that means breakdown. बल्कि यहाँ पे I'm going to add over here. Uh, the term lysis over here, this part, that literally in Greek, I think in Greek, I'm not sure. That just means decomposition or breakdown. Okay, that literally means. So hydrolysis, that means the word hydrolysis is hydro is water. Okay, hopefully everyone knows that. So lysis is that something is going to break down when you add water to it. So what happens is, last point is some covalent molecules, they hydrolyze or react with water. Either जो word है ना, ionize as well. You can write ionize when mixed in water. So basically, they react with water to form ions. And the prime example is all your acids. Okay, so I'm just going to give you one example. For example, I've got HCl. Now, HCl is a perfectly covalent molecule. Uh, HCl in its normal state is a gas. But when you turn it aqueous, when you mix it in water, what happens is it breaks down. It produces an H plus one ion and it produces a Cl minus one ion. Okay, so it used to be a neutral covalent molecule, and it ionized in water. Otherwise, it was never going to form ions. But it reacted in water and turned into something else, which is H plus one and Cl ions. It broke down. Okay, so all acids, a lot of acids, a lot of covalent molecules, they do hydrolyze. And when that happens, they break down and they turn uh, into these ions, which will then conduct electricity. So once they form ions, once they form free moving aqueous ions, then conduct electricity. Okay, so but once they form, otherwise covalent molecules are never going to conduct electricity. Some of them are going to react. So keep this in mind. Acids, although they're covalent, okay, HCl में H doesn't have +1, Cl doesn't have -1. It's they're sharing electrons. But when they react with water, when they collide with water, they break down in the middle and they turn into H+1 and Cl ions. And now they are ions. ठीक है? So once now they've become ions, they will conduct electricity. तो मैं बस summary दे रहा हूँ. Ionic compounds are going to conduct electricity molten in aqueous state because they have free moving ions. Metals will conduct electricity, but nothing will happen to them. And they will conduct electricity because they've got free moving mobile electrons. Graphite is going to conduct electricity, but nothing will happen to it as well because it's got free moving electrons. Some of the covalent molecules, most of them are not going to conduct, but some of them will react with water and they will break down in water and they will turn into ions, which are then capable of conducting electricity because now they've turned into charged particles, which are freely moving around. Okay. So, question 3, anyone, is this all clear?
Yes.
So, ठीक है. चलो ठीक है. We'll start tomorrow the same thing. And पुराना recap था, तो we'll continue from the same point, and hopefully tomorrow we'll start with the actual chapter. ठीक है. चले. Okay, everyone. Your
Allah
questions is
Hafiz, sir.
okay. Allah Hafiz.